Hi everyone, we are reviewing our logarithms and exponents when we're not using e, so everything that's not natural log in e to the x. Okay, and then we're going to talk about derivatives and such. Okay, so first we're just going to do a quick review of rewriting in logarithmic form. Right, so remember your base stays the same, right? So your base stays the same, x here is your answer, I guess, and then y here is your exponent. Okay, so we're given something in exponential form and we want to solve for x. Now, if this number is of base 2, it makes it really easy, but 45 is not. So we have to rewrite this in logarithmic form. Right, so I'm going to write a log. My base is 2. My answer is 45, and that's equal to my exponent. Divide everything by 3 and plug that in our calculator. I got 1.30. Okay, now we're going to go the other way. We're starting in logarithmic form, and we want to go to exponential form. So you can do the big 5 thing, and this cancels or whatever. But you're really rewriting in exponential form. Right, so x minus 2 is our answer, equals, my base stays the same, and I'm to the third power. So x is 5 cubed plus 2, which is 127. Okay, let's talk about derivatives and integrals. So you've seen this before, you've seen this before, you've seen this before, hopefully. Now we're moving on to something that's not base E, and it's essentially the same, you just have to remember one extra thing, and it kind of makes sense why it's not here. So here, if you have log base A of u, then the derivative is going to be 1 over u, so very similar to over here, except you have to remember to put a natural log of your base, a natural log A, also in the denominator. And that makes sense because if you put 1 over u and then natural log of e here, because e is my base, well, this is just going to be 1, right? So you end up just with 1 over u. Okay, similarly here, if you have a to the u, you just have to remember when you take the derivative to multiply that by natural log of a. Right, so it's the same thing as e to the u, except you have to remember to add that or multiply in this natural log of a. Okay, and then similarly, when you are integrating, you have to divide by natural log of a. Okay, when you're integrating. So here we multiply by natural log of a, here we have to remember to divide by natural log of a. Okay, so one extra thing you have to remember, but overall it's not too bad. So we're going to start with the derivative of 2 to the x cubed. So we just remember to write 2 to the x cubed. So same thing as before, right? Okay, you just rewrite what you're given because it's an exponential. Then we have to remember to include times natural log of whatever my base was. Then we have to remember chain rule. So now I'm going to take the derivative of x cubed, which is 3x squared. All right, let's move on. Now we're going to do a logarithm. So we have log base 3 of x squared plus 1, and we're just going to follow this formula right here. So I do basically the same thing that I do when I have natural log. Okay, so 1 over, and then I rewrite what's inside my log. So x squared plus 1. Then you just have to remember to do natural log of your base. And now we have to remember to do chain rule. All right, so the derivative of x squared plus 2 goes right here. Okay, that's it. Now let's do some integrals. So we have the integral of 2 to the x. So we're just going to follow this formula right here. Right, so the integral to the x is 2 to the x divided by natural log of your base, so natural log of 2, then plus c. Okay, I have a product here. So I do notice though that what's outside of my function is 1 degree less than what's inside my function, so that's a good bet for a u sub. Okay, so I'm going to end up with 1/3 integral 3 to the u du. Okay, so when I integrate, again, same thing here. So 3 to the u divided by natural log of 3 plus c. Right, and we could reduce this sum. We don't have to simplify it at all. I'm just going to make my substitution. So 3 to the x cubed over natural log of 3 plus c. Right, and that is it. Okay, so what happens if you are trying to differentiate something with a variable in it in the exponent and in the base? Well, that's not something we have a formula for. So for instance, like kind of the parent function for this would be x to the x, and I'm asking you to differentiate this. Well, this is like you would have to like simultaneously maybe use power rule and exponential. It's weird, you know. This is not a parent function that we normally work with, so we don't have a rule for that. So what we're going to do is do logarithmic differentiation, which sounds hard, but it's really not. Only thing you have to do is natural log both sides because we want to bring this exponent down. Okay, we want it to be something we can work with. So I'm going to take the log of both sides. That's a minus. Okay, and what that allows me to do is bring this down. And now it's something that I can work with. Now I can take the derivative of both sides. Okay, so if I take the derivative of natural log of y, that's going to be 1 over y, and then dy dx, which is what I'm trying to find. Okay, this is my goal. Equals. Here I have a product of two functions. So I could distribute this if I wanted to, or you cannot. It's totally up to you. But I'm going to go ahead and just take the derivative like this. So we have to product rule. So the derivative of x minus 3 is 1. Plus, now we have x minus 3, and then the derivative of the natural log of x plus 1 is going to be 1 over x plus 1. Okay, and I want to get dy dx by itself, so I have to multiply y to both sides. Now I do know what y is equal to. Y is equal to x plus 1 to the x minus 3. So in getting dy dx by itself, we end up with this. Which is kind of an ugly answer. It ends up having this in the answer, which is totally fine. If we were to try to take the second derivative, you know, that'd be complicated, but this is fine for an answer for my first derivative. All right, that's it for this. I will see you all later.